There, this is Srestha, and today I'm doing this video to demonstrate the Minesweeper game that I created for the final milestone of software engineering course. This is the first version of the milestone, and as you can see, the user interface for this game is fairly simple because there are not much functionalities in this game. So let's dive right into it and see the game working. So this right here is a level selector of this game, and this is the game title, and there is a start button that starts the game, and so it is set up that so that the default level is easy. When I click the start button, a grid is displayed with a 10 by 10 size, so 10 rows, 10 cells in a row and 10 cells in a column, and there is also a scoreboard displayed in the top right hand corner of the UI, and the user can interact with this grid. So whenever a user clicks on a cell, it displays a number of mines that the neighboring cells have. So it displays 1. That means there should be a mine in one of these 3 cells, and we can also mark a cell as if we suspect that there is a mine. So if I right click on this cell, it will change this color to yellow, and it means that the user suspects that this cell contains the mine. And as you can see, there you go. I'm not really good at playing this game. So whenever user clicks on a cell that contains mine, it will display or reveal all the mines, and also display that the user has stepped on a mine and the game is over. I've also added a little bit of audio effects to make the game more interesting, and it also now the timer or the scoreboard is stopped. The user can always change the level, which gives the option for 3 levels. So let's select medium and restart the game. So as you can see, whenever we restart the game in the medium level, it displays a grid of 15 by 15 size, so 15 cells in a row and 15 cells in a column. The timer is restarted, and basically the functionality or the interaction between user and the grid will be pretty much similar. You can still mark the cell as mine, and then there you go. I'm really not good at playing this game, but that's pretty much it for the functionality of this version. Thank you. So now I'm trying to demonstrate the second version of the Minesweeper game that I created for the final milestone. In this version, I have created a hexagonal grid with hexagonal tiles, as it was required by task 2 of the final milestone. So for this version, I haven't really added any fancy audio effects like I did for the previous version. The functionality of this version is fairly simple. So let's look at the game working. So whenever I click on a cell, it as usual reveals the content inside it with the number of mines around it in the neighboring cells, and this message right here displays the number of cells, non-mine cells, that we have revealed. So 107 is the total number of cells or tiles in this grid. So 0 means there are no mines in the neighboring cells. 2 means that there are 2 mines in the neighboring cells. So also how I have designed this version is that if there is a mine in a tile, it will display 10 whenever a user clicks on that. So if I click on a mine, oh, there you go. So if since this cell contains a mine, it displays 10 with a red background. So in this way, the user will know that he or she has clicked on a mine. And how I have set this version up is that whenever a user clicks on a mine, it will show up right here in the, okay, just a second. Yeah, right there, it will show up in the console of the browser, because I've already told that I created these versions or the entire game as a web-based application. So that's pretty much it for the for this version of the game. Thank you. I'm trying to demonstrate the final version of this game, which is based on a coloring rule that no cell will contain the same background color as its neighboring cells. So whenever this rule is broken, then the game will be over. So let's start the game. When I press on the start button, it will display a 7x7 grid, which will be the interaction point of user and the game. And it also displays a scoreboard, or it can also be taken as a timer in the top right hand corner. And when the user clicks on a cell, it will display the background color of the cell. As you can see, most of the cell contain different background colors, but there are also mines set up so that this coloring rule will be broken if some of the cells are clicked. As you can see, when I clicked on this cell, it's displayed that the game is over and that the coloring rule has been broken. Now it displays the color of the cell, and as you can see, this cell contains the same color as this cell, and they are neighboring cells, and hence the coloring rule has been broken and the game is over. This is pretty much it for this version of the game. Thank you. Hey there, now I'm trying to demonstrate the testing part of these applications. For testing of these applications, I have used Jasmine, which is one of the most popular frameworks for testing web-based applications. So let's see the tests running. Alright, as we saw that at first the medium level was selected, which tested the select level function, and then the start button was clicked and the grid was displayed. Then I have set the test up so that each individual cells will be pressed serial wise, and so until a mine is hit, and it will display the message that the game is over, you have saved on the mine. And then I have also tested the functionality of the restart button, and the restart button has been clicked, and then it redraws the entire grid and also resets the timer. So in this way, the entire functionality of the game has been tested. Now I'd like to talk about the documentation part of the entire project. So let's look at the documentation. Let's talk about design paradigm first. The program is designed based on the concept of object-oriented design. There is only one object, which is an instance of a class called Minesweeper. When the browser runs, the instance of this class is created, which acts as the game object. And then the player interacts with the view, and the view then transfer the information about the interaction to the controller, and then the controller talks to this object and then updates the view as well. The diagram for which represents the game object is given right here. If we take a look at the source code, we can find that there is a class that is called Minesweeper, and it has its properties, which is level, high score, timer, grid, and then it has its methods. Some of them are change background, reveal cells, set up mines, start timer, and so on. So this is the paradigm that has been adopted for this project. And now let's talk about the software architecture. For architecture, one of the most popular architectures, which is best suited for web-based applications, has been adopted for the applications, which is Model View Controller. Model View Controller is really popular because of the fact that it allows the developers to manage the source code really efficiently, and it automatically creates a separation of concern. A little bit of justification about adopting MVC is also provided in the documentation. and it also has a section for the tools that has been used. One of the main tools that have been used for developing these applications is jQuery. jQuery is actually a fast and small framework or library of JavaScript, which makes the process of manipulating the HTML document easy. Uh, Originally, I was planning to develop these applications or games in Java, but because of my familiarity of HTML and CSS and JavaScript, I shifted towards them. Uh, and MVC has made the process of managing the entire source code really easy. Now we can talk about the principles that I considered while developing the games. So the first one is separation of concern. This principle was really easy to follow because of the MVC architecture. The MVC architecture automatically divides the entire source code into three different sections, which are model, view, and controller. Model is the data structure of the application. Controller is the controller, as the name suggests, of the entire application logic. It acts as the bridge between the model and the view is the user interface that the user sees and interacts with. Whenever the user interacts with the view then transfers the information about the interaction to the controller, and then the controller talks to or interacts with the instance of the model and then performs the appropriate actions. There are screenshots of the model, view, and the controller given in the documentation. Now let's talk about another principle, which is in information hiding and encapsulation. This principle is one of the main features of object-oriented design. Um, if we examine the source code and take a look at the class Minesweeper, we can see that a hash sign has been used in front of the property names. A hash sign has been placed in front of level, high score, timer, and grid. This is a way of defining private properties in JavaScript, which is fairly new. This allows to create a security around these properties so that other external agents cannot access these properties directly and modify them. In order to access these properties or modify them, one has to use the methods that it has been provided by the class Minesweeper. For example, in order to modify the timer function, one has to use the start timer function or the restart timer function. If we take a look at the start timer function, it sets the timer so that it acts as the scoreboard, and it is displayed in the top right hand corner of the UI. And later on, whenever we press the restart button, then the restart timer function is called, and then it clears that timer, which is the private property of Minesweeper class, and then it again sets that timer as required. So in this way, the concept of information hiding, which hides the properties which are declared as private, and encapsulation is the process of accessing them via a getter and setter methods to ultimately form that barrier of security around the properties. Then there is also another principle of low coupling and high cohesion. As I've already mentioned, there is only one object in the entire application. Coupling refers to the interdependency between two or more objects in the application. If there is only one object, it automatically drops the coupling down to the minimum. Hence, there is low coupling in the application. And in terms of cohesion, if as we have already mentioned and seen, that the properties and the methods are highly interdependent upon each other. So the start timer function uses this timer property of the class Minesweeper, and then the restart timer function depends upon the start timer function, because it is trying to clear out the timer property which was set by a start timer function. So there is a really high interdependency between the property and the methods, and between two methods as well. Similarly, we can see that draw grid function depends on the value of the level value, which is the level property, and so on. So there is a high cohesion between properties and methods in this application. Then there is also the principle of fail self default, which is followed by using unit testing, which was already mentioned in the previous previous section of the video, and is also mentioned in the testing section of the documentation. Few screenshots of the unit testing has also been provided in the documentation. Now let's talk about the design modeling, which can be seen under the section of static modeling and dynamic modeling. One class diagram has been provided in documentation. Since there is only one application in the entire project, the entire game experience is formed by interaction with this game object. There is no interaction between two different objects, so there is only one class in the class diagram. As you can see, there is a Minesweeper class, and then it has its properties, and then it also has its methods. So that's basically it for the class diagram. Then there is other models that has been provided under dynamic modeling. One of them is sequence diagram, and it shows the sequence of activities, or the interaction between the player and the Minesweeper object or the game. So at first the user sets the difficulty and then presses the start button to start the game. The game then displays the timer and the grid to the player, and then the player clicks a cell, and there are two alternatives or two course of action. It depends on whether the cell contains the mine or doesn't contain the mine. If the cell doesn't contain the mine, it reveals the game reveals the cell content to the user, and if it contains mines, it will reveal all the mines and then notify the user that the game is over and asks if you want to restart or not. And then if there is no mine, then it will check if the game is over, and then carry out the appropriate actions. And then there is also a collaboration diagram, which is provided under collaboration diagram section, and also a state chart diagram, which is a fairly simple diagram because there is only two states, which is the game idle state and then the running state. When the user presses the start button, then the game object goes from idle to running state, and on entry it will start a timer and display the grid, and on exit it will stop the timer and remove the grid, and whenever it restarts, it will just go back to the running state. So that's a state chart diagram. Then there is also an activity diagram given, which displays the sequence of activities. So player starts and then selects the difficulty, starts the game, displays the game displays the Minesweeper, displays the grid, starts the timer, then the user clicks on the cell, and then the game checks the cell. If it contains mine, then it reveals all the mines and displays the appropriate notification to the user, and asks if user wants to restart the game. And if yes, it will go back to the start, and then if no, it will go and terminate. In case if the cell which was originally clicked by the user doesn't contain the mine, it will reveal the cell and check if the game is complete. If no, it will just again start from clicking. The user will click a cell, and then if yes, it will display the appropriate notification to user, and then ask if the user want to restart the game or not. That's basically it for the activity diagram. And then the major functions that are involved or given in the source code has also been explained a little bit in the documentation. And then there is a testing part, which is already demonstrated in the testing section of the video. The library called Jasmine has been used for testing the functions, um, and the text, all the sections or all the functions of the game are tested using the same framework, and a few screenshots have been provided uh, to examine. That's pretty much it for the documentation part of the entire um, project. For the purpose of version control, GitHub was used as the platform. No additional branches were created because the entire project is an individual assignment. Whenever there was a major change done during the development, the changes were committed to the local repository, and then they were pushed to the origin, and the main master branch in the GitHub platform was updated. That is pretty much it for the version control of the entire project. Talking about the platforms that the application is designed for, it is basically designed for every platform because uh, it is a web-based application, and the web-based application doesn't really depend on any platform or any device. It can be accessed in Mac or Windows or any Linux system or anything like that. It is one of the major reasons why I chose JavaScript, HTML, CSS as the platform for developing these games, because they can stretch or cover can be used in different platforms.